So a couple of videos ago, we learned the sum and distance formula for cosine. All right, so I'll do a little box over here. All right, so for cosine, we had the cosine of A plus B. And remember, that was equal to cosine A cosine B minus sine A sine B. All right, it's cosine, cosine, sine, sine, sine. The middle sign has to change. And then we also had, similarly, we had the difference formula. So for the cosine of A minus B, we had cosine A cosine B plus sine A sine B. All right, so remember for cosines, it goes cosine, cosine, sine, sine, sine. Cosine A, cosine B, change the sign, sine A, sine B. Okay, so now we are going to learn the sum and difference formula, for sine, since we already did cosine. All right, so here we have the sine of A plus B. And so remember, this is when we're adding together two angles. Okay, so A and B are angles, and they can be measured in radians or degrees. It doesn't matter. Okay, so when we have the sine of A plus B, that is going to be equal to the sine of A times the cosine of B plus the cosine of A times the sine of B. Okay, so if we want to think of like a little catchy way to remember this, all right, for sine, it goes sine, cosine, cosine, sine. All right, so I do the sine of A, the cosine of B. It's like I'm going left to right. All right, so I go sine, cosine. I don't change the sign, and then I have to go back and I have to do the cosine of A and the sine of B. So sine, cosine, cosine, sine. And it is going to be the same thing for if it was the sine of A minus B. All right, it is going to be sine, cosine, cosine, sine. Okay, it's just like going left to right. So I do sine, cosine, keep it a minus, cosine, sine. Okay, so when I kind of remember this, when I think of the signs, I go sine, cosine, cosine, sine. And then remember for cosines, it goes cosine, cosine, sine, sine, sine. All right? It's kind of the opposite of what you would think. The sine one doesn't change the sign in the middle. All right, but so these are two new formulas. They are on the reference sheet that you will get for the exam, but I still want you to be able to do them for maybe like a formula quiz. So let's do a couple of examples. And these examples are going to work the same way that they did for the cosine sum and difference formula. All right, all we need to know is how to plug this stuff in, and then you are good to go. So let's do our first example. If the sine of x is equal to 4/5 and the cosine of y is equal to 4/5 and angles x and y are in quadrant 1, let's find the sine of x plus y. Alright, so using these handy dandy formulas that I just gave you guys, I know that the sine of x plus y is going to be equal to sine x cosine y plus cosine x sine y. Alright, I've got sine, cosine, stays the same, cosine, sine. Now I can plug in what I already know. So I know that the sine of x is 4/5. And I know that the cosine of y is 4/5. And I just have this plus sign. So now I got to figure out the cosine of x and the sine of y. And hopefully some of you have already started this process because we are just going to use those wonderful Pythagorean identities that we love so much. Alright, so I'll start with the x's. I've got sine squared x plus cosine squared x is equal to 1. I'm plugging in 4/5 for sine x, so I get 4/5 squared plus cosine squared x is equal to 1. This is really 16/25. Sorry about that. Subtract it over. You get that cosine squared x is going to be equal to 9/25. Take the square root of both sides. You get that the cosine of x is going to be equal to plus or minus 3/5. But remember, I'm in quadrant 1. Problem told me I was in quadrant 1. And in quadrant 1, my cosines are positive. So I'm just going to use cosine x is equal to positive 3/5. So I'll come up here and I'll plug that in. And now I have to go ahead and find the sine of y. So I will go ahead and I'll do that right here. So now I've got sine squared y plus cosine squared y is equal to 1. I'm plugging in 4/5 for cosine of y. So this is sine squared y plus 4/5 squared. This is going to be very similar to what I just did. Alright, so I get sine squared y plus 16/25 is equal to 1. Sine squared y is going to be equal to 9/25. So sine y is going to be equal to plus or minus 3/5 because you take the square root. And since I'm in quadrant 1, signs are positive up there. So again, I only care about the positive 3/5. So I'll plug that in. And now I can just go ahead and solve this because I've just got some multiplication that's to take care of. 4 times 4 is 16, 5 times 5 is 25, 3 times 3 is 9, 5 times 5 is 25. They've got common denominators, so I am good to go. 16 plus 9, that's 25 over 25. Boom, baby, the answer is 1. Okay? So, very similar to those cosine sum and difference formulas, except now we just have a new one that we need to know. Alright, like I said, this is provided to you on your reference sheet for the trig exam. Okay, let's do another. Let's see, if the sine of x is equal to negative 1/3 and the sine of y is equal to negative square root of 5 over 3. And let's have x and y be in quadrant 3 this time. We're going to do a couple little parts. Find, and for part A, let's find the sine of x plus y. Okay? And then for part B, we will find the sine of x minus y. And then for part C, just for fun, I want to do the sine of y minus x. Alright, so 3 parts. First off, let's go ahead for part A and let's fill in what my formula is going to be. Alright, so the sine of x plus y, I've got sine, cosine, cosine, sine. So sine, cosine, cosine, sine. And then let's plug in what the problem gave me. I know that the sine of x is negative 1/3. And I know that the sine of y is negative the square root of 5 over 3. Here's my plus sign. So let's go ahead and find out the cosine of x and the cosine of y. Alright, again, Pythagorean identities. I'll do the x's first. So I've got sine squared x plus cosine squared x is equal to 1. I know that sine squared x is negative 1/3. So it's going to be negative 1/3 squared plus cosine squared x is equal to 1. All right, don't forget when you square a negative, that's a negative times a negative. So this is going to become positive 1/9 plus cosine squared x is equal to 1. Subtract over the 1/9, so this is going to be cosine squared of x is equal to 8/9. And then I'm going to get that cosine x is equal to plus or minus the square root of 8/3. Okay, and I'm in quadrant 3. In quadrant 3, cosines are negative. So I want the negative answer. Cosine x is going to be equal to negative the square root of 8/3. Okay, and we can break, we always want to have simplest radical form, and this 8 can be broken down. 8 is 2 times 2 times 2, and then we can pull out a pair of 2. So this is negative 2 the square root of 2/3. All right, so I just broke that 8 down. So I'll go ahead and plug that in for the cosine of x. Negative 2 square root of 2/3, okay? And now I can go ahead and find the cosine of y. So another Pythagorean identity. So I've got sine squared y plus cosine squared y is equal to 1. And I'm plugging in negative the square root of 5/3 for sine y. All right, and just like before, I'm squaring a negative, so that means I'm going to get a positive. Okay, but it's also nice because since I'm squaring a square root, this is just going to become 5 in the numerator, and then I got 9 in the denominator. Subtract that over, I'm going to get cosine squared y is equal to 4/9. Or cosine y is equal to, whoops, got ahead of myself, plus or minus 2/3. But I'm in quadrant 3, and in quadrant 3 cosines are negative, so I only care about the negative. So up here I'm going to plug in negative 2/3. And now we can go ahead and multiply, make this look nice. That is going to be negative 1 times negative 2 is positive 2. 3 times 3 is 9. Plus, now when here I've got a negative times a negative, so it's also positive. And this 2 is just going to stay on the outside 2. And then you multiply what's underneath your radicands. That's going to be the square root of 10/9. And we can just, throw this all together since they've got common denominators. This is 2 plus 2 times the square root of 10 all over 9. Beautiful. Okay, so I just used the new formula that I have. I plugged in what I knew. I had to use some Pythagorean identities to find out the other stuff, and then I simplified. I'm going to kind of draw a squiggle so it separates my work. Okay, so now let's write out sine of x minus y. Okay, very similar to the formula that we used above, except now we have a minus in here. All right, so it's going to be sine, cosine, cosine, sine. All right, so sine x, cosine y stays a minus, cosine x, sine y. Sine, cosine, cosine, sine. And the nice part about this is that I just found out everything that I need to know for this, because it's still using the same starting value. So now I can just go ahead and plug in. All right, so my sine of x was negative 1/3. My cosine of y was what I figured out in the black over there, and that was negative 2/3. Minus cosine of x is what I figured out in the orange. That's going to be negative 2 the square root of 2/3. And then the sine of y they gave me, which was negative the square root of 5/3. Okay, really the exact same thing that was in this line, except it's got a plus, or except it's got a minus instead of a plus. Whoops, got to switch. There we go. So now we can just multiply. Negative 1 times negative 2 is positive 2. 3 times 3 is 9. Minus, and now I'm going to have the same thing. I'm going to have 2 times the square root of 10 all over 9. So now here I'm going to get 2 minus 2 times the square root of 10 all over 9. And there's my answer. Okay, I know it might seem kind of silly to plug all that in, but always good to show as much work as possible. See how I'm doing on time. Oh, not bad, not bad. So now we can go ahead and do the last part, the sine of y minus x. Now don't get confused just because it looks a little funky, alright? We're still going to do what we normally would. Alright, so let's write out what our formula is. Remember, we go left to right. So this is going to be sine, cosine, cosine, sine. Alright, sine, cosine, cosine, sine. Alright, now because the y came first in the difference formula right here, the y comes first when I start expanding my formula. Okay, so notice this is not the same thing that we had in parts A and B. Okay, not the same thing. If you look, it's kind of almost the same though. Pretty much what we did is, because our x and y switched right here, my piece that was, let me get a different color, my cosine x sine y, that came second in the last two examples, that's first now. Okay, and the part that was first in my first two parts, now that's bumped to the end. Okay, but just make sure you're careful when you expand all these. Take the time and make sure that you're going in order. And now we're just going to plug in what we know. So the sine of y is negative the square root of 5 over 3. Cosine x is negative 2 the square root of 2 over 3. Minus the cosine of y is negative 2/3. And the sine of x is negative 1/3. So here, when I multiply the left side, I'm going to get 2 times the square root of 10 over 9. Minus, and then here I'm going to get 2 over 9. And then when you throw these all together, that's just 2 times the square root of 10 minus 2 all over 9. Which is not the same thing that we got in part B, all right? Remember, subtraction is not commutative. So the fact that for part B, the 2 square root of 10 was the second term, and for C, the 2 square root of 10 is in the first term, that's kind of a big deal. All right, so we did not get the same thing, but that is all I got for you guys. So another identity to keep in your pocket. And we will use more of this tomorrow. Have a great night.